A multivariate analysis of variance, or a MANOVA, in contrast to the ANOVA, which examines the effects of one or more independent variable on a single dependent variable. A MANOVA examines the effect of one or more independent variables on multiple dependent variables. The MANOVA treats the dependent variable as a correlated set, revealing relationships among the independent and dependent variables that may have been missed by the ANOVA. Using a MANOVA rather than two or more ANOVAs reduces the chance of committing a type 1 error. And those are the statistics that are used for calculating it. An analysis of covariance is used in studies when one of the independent or classification variables is related inextricably to the dependent variable. The analysis controls for the correlation of the two variables. The outcome is interpreted the same way as the ANOVA results, but this is different when one of the independent variables is related to the dependent variable. So think covariance, they vary together. Effect size and power of statistical tools. It's now advised to report the effect size. This is increasingly common procedure to indicate the statistical significance of the results, basically the practical significance of the data. So the effect on the larger population, the practical significance of the data. Estimates are scale-free, standardized values, and they provide an indication of the extent that the value of the dependent variable is explained by the independent variable. It's not interpreted as being statistically significant or insignificant. It provides a mean for interpreting the statistical results independent of statistical significance. So basically, does this have an effect on the larger population? Power analysis is a really great tool. You can do it before your study to determine subject sample size that's required to reach the level of significance. Or you could do it post hoc after your study to further evaluate the research to determine if the failure to reject a null hypothesis was related to an insufficiently large sample. So before I started my dissertation, I remember deciding like arbitrarily, like, oh, I need 30 subjects, okay? And then we did a power analysis. So once I started, piloting my data, I realized how complicated things were. We did a power analysis, and it turns out that I really only needed 7 subjects to hit significance. So that saved me a tremendous amount of time by doing an a priori, before the study, power analysis. Now, it could also be used post hoc. Let's say you do the study and you didn't find significant results. You could go back and say, oh, well, had I found the, post hoc power analysis shows that if I had actually had 30 subjects, my results would have reached significance. So to explain results that weren't significant.